Hello my dear students, welcome to your Geography's online class. In today's class, we will be discussing a new chapter, that is the interior of the earth. When we talk about the interiors of the earth, to us, it can be very easy for us to see that it's not very clearly known what lies beneath us. As because there is no such direct source to understand the interior of the earth. Even the excavation work on this earth has taken place to just some 6 kilometers deep, either for extracting some minerals or a mineral oil. But the major part of this Earth's interior is unknown, as because we could only reach 6 kilometers, while the radius of the Earth is some 6,370 kilometers. So that means we are not able to reach with another 6,364 kilometers deep inside us. So there is no such direct observation that gives us an idea about the interior of the Earth. Despite this, there are certain indirect sources which helps us in understanding the interior of the earth. On the basis of such indirect sources, the earth's interior has been classified, or you can say it's been layered into three different layers. The outermost layer where we stand is the crust. The intermediate layer is the mantle, and the innermost part of the earth's interior is known as the core. The crust is solid. The upper mantle is solid, while the lower mantle, because of increase in the temperature, it somewhat behaves like liquid. The core as well is divided into inner core and outer core. The outer core, which is in contact with the lower mantle, which is almost in its liquid form, is also, the core, the upper core or the outer core is also to some extent in liquid form, while the innermost core, because of the heavy materials found and the overlying pressure on top of it of different layers, it behaves in solid. So based on all this fact and the various indirect sources, we have understood about the interior of the earth. So let us discuss these indirect sources and understand how they have helped us in knowing the interior of the earth. So of the first indirect source, it is the density when we talk about. And when we discuss about density, the Earth's average density, according to Newton's law of gravity, is 5.5. While this density varies now again from the outermost layer to the innermost layer. The outermost layer, that is the crust, basically has a density of 2.7. And it keeps on increasing as it reaches the layer of mantle width, reaching to 3.5. And then ultimately towards the interior part of the core, the density reaches to some 11 to 12. Now this is a fact to understand that the density is increasing because the inner part or the interiors of the Earth's crust is much more denser than the outer crust. Or you can say the outer layers of the Earth. Hence, so two options or the two things that helps us in understanding is that the density increases towards the interior because, one, that there are heavy materials found in the interior of the earth and hence the density decreases. The next is because of the overlying layers, the density increases. Next off, or the next indirect source is the temperature. With temperature, very much like that of density, also increases in the interior part of the earth's surface. And this is much evident for us to understand from the volcanic eruptions and the earthquakes that takes place. The volcanic eruption, when it takes place, we have all witnessed that the hot molten magma coming out of the Earth's surface. In fact, the Earth's interior. So this is only possible for a state of matter to change from solid to liquid with a change in temperature. The crust is in solid form, the temperature is less, hence there is no such melting. While the inner part of the crust and as reaching to the layers of metal, there it's mostly found in the molten state, which is evident, like I said, with the volcanic eruption that has taken place. So this molten state is only possible because of high temperature. And it is also seen that the temperature increases to almost 2900 degrees centigrade towards the interior part of the Earth. But there is a varying change in the temperature condition. It does not change all of a sudden. The change in temperature is witnessed with its varying depth. Until 100 kilometers of depth, the temperature changes with 12 degrees centigrade. And for next 300 kilometers deep inside the Earth's crust or the Earth's interior, temperature changes by 2 degrees centigrade. And then finally below it, there is a gradual change in temperature with just 1 degree change. And with this, we find that the Earth's interior has a temperature of 2900 degrees centigrade. The third factor, or in fact the third source, indirect source, is the pressure. Very much like density and temperature, pressure also changes towards the interior of the Earth. Again, there are two factors that leads to the change in the pressure. The pressure towards the interior of the Earth increases either because of the overlying layers, like we said, that the Earth's interior is divided into three layers: crust, mantle, and core, and the core is the innermost layer. So here what happens? There are two more overlying layers above the core, obviously that's mantle and crust. So they exert some pressure to it, and hence the pressure increases towards core. The next is, it is also because of the heavier materials which are present in the core. The fourth factor to discuss of the indirect sources is earthquake waves. And this is quite considered to be one of the most important source to discuss about the Earth's interior, the earthquake waves and its behavior. When we talk about earthquake, the science related to the study of earthquake is known as seismology, and any evidence that the waves provide to us, the seismological waves provide to us, is known as seismological evidence. So how would we know about this? Is the earthquake waves are divided into three different kinds: the P waves, S waves, and L waves. And they differ in their characteristics. The P waves is considered to be the primary waves and moves in a longitudinal waves like that of a sound's propagation. It travels at a speed of 8 kilometers per second and can pass through all the three mediums. While S wave is a secondary wave which travels in a transverse direction to the wave of the earthquake and can travel only in solid and disappears itself in liquid. It has an average velocity of 4 km per second. While the third one is the L waves, which is known as long waves. These long waves, since it travels on the surface, hence it is also known as surface waves, and its velocity is 3 km per second. And like P waves, the L waves can also travel in all the three mediums. Now, this L wave or the surface waves can also be distinguished into another two different types. One is known as Rayleigh waves, the other is known as love waves. These have been named after the person who had mentioned about this or who had discussed about this. Rayleigh waves is named after the English physicist Lord Rayleigh, and love wave named after the physicist A.E.H. Love. Now these three different kinds of earthquakes, waves, that gives us an evidence of understanding how the interior looks like with the behavior they possess when they travel from one end to another, or from one state of matter to another. Or in other words, to be specific, we can say when they travel from one layer of the Earth's interior to the other layer. So when we discuss about the behavior of the earthquake wave as the fifth indirect source in understanding the Earth's interior, what it is to understand, or what it gives us an idea, is that the waves that travel in the solid has a different characteristic than as compared to the wave that travels in the liquid. We in fact witness changes coming along their way when they transverse from one state of matter to another state. That means either from solid to liquid or from liquid to solid. So just to make note of the point where we discussed about P wave and L wave can travel in all the mediums, but the S waves cannot travel in the liquids. It can only travel in solid. So hence, when the earthquake occurs from the focal point, or the point where the earthquake occurs, these waves get scattered into different directions. As the wave starts scattering towards different directions, the wave moving towards the interior of the earth, considering all the waves like P, S and L waves, when recorded from the focus, as they travel towards the interior, until the depth of 11,000 kilometers distance traveled from the focus, in fact, until 11,000 kilometers of distance traveled by the waves, all the three waves travel almost constantly without any changes. But beyond this, beyond 11,000 kilometers of distance to travel, we find that the S waves disappear and there is a change in the velocity of the P waves. So what this gives us an idea is, as S waves is disappearing, we can understand that the layers beyond the distance of 11,000 kilometers come to be metal, as it is acting as the liquid. It's a liquid area. So hence here S waves cannot travel, so it disappears, while P waves, its velocity decreases and gets refracted away from the normal position. So as this refraction takes place, the wave starts traveling in a diverse nature or refracted way. There is a change in its path, there is a change in the velocity, which results in the formation of a shadow circle. Now shadow circle is a zone which remains unaffected by the earthquake and is located between 103 degree to 43 degree from the focus. So this also gives an idea, the refraction can also gives us an idea of the inner core or the core being composed of heavier materials. So based on all these discussions, it can also be understood that the Earth's interior is mostly made up of heavy materials, and the shadow zone, which forms to be the part of the journey for the earthquake, remains unaffected as because of the refraction of the P waves while entering the liquid areas or the metal areas. So this is for the class today. Thank you, and we'll discuss furthermore in the next chapter.